Okay, so for question 46, I only wanted you to do sub-question B and sub-question C. Sub-question A is messed up, so don't even worry about it. So for sub-question B, the question for all these is to assign relative priorities to each set of substituents. So just to make sure we're all on the same page, this little squiggly line is telling you that there's an arbitrary attachment point between whatever and this carbon. So whatever is to the left of these squiggly lines is not important, doesn't really matter. The first attachment point you want to look at is the atom directly to the right. Okay, and so now again, remember that whenever we're doing relative priority, we are not comparing relative size. That's not the criteria. The criteria is that from the attachment point, you look at the atom immediately adjacent. So the first one away, if you were looking at the center of a circle, you're going out radially. So that's what we're going to do. We're going to go first atom out. So for this first one, we have a carbon. So we have a C. And for this first atom here, we have a nitrogen, then oxygen, then a carbon. So we have a tie between this carbon here and this carbon here, which eventually we're going to resolve that. But for now, if we're going to assign these, 1 equals the highest priority, and 4 equals the lowest priority. The highest priority is going to go to the atom with the highest atomic number. So obviously, nitrogen and oxygen both have a higher atomic number than carbon. Between nitrogen and oxygen, though, oxygen is going to have a higher atomic number. So this guy is going to be the highest priority. And so then that means that nitrogen is going to have the next highest priority. And at this point, it becomes a little bit more difficult because we have a tie between this carbon here and this carbon here because they both have the same atomic number. So let's go ahead and assign a letter for each so we can talk about them and talk about how they branch. So this is carbon A, and this is carbon B. So let's just do a branching tree for carbon A. So carbon A has this kind of branching tree where attached to carbon A we have 3 different atoms. And I'm just going to put them highest priority on top to lowest priority on bottom. So the first attachment point we can think of is obviously nitrogen. And we're just going to neglect what's attached to nitrogen unless we really, really need to compare further along the tree. And so then what else is attached to carbon A are 2 hydrogens. So we'll have hydrogen here and hydrogen here. So recall that these hydrogens are implicit to this carbon. So we have 2 extra hydrogens here and here. They're always there, but you don't have to write them out. And in fact, it actually looks prettier, a little bit more elegant if you don't write them out. Okay, so that's carbon A. So then let's actually change color, come over here and do carbon B. So this is carbon B. So just like with carbon A, we're going to have 2 hydrogens, but for carbon B, we're also going to have an oxygen. So this is going to be the first attachment point right here. Oxygen, then we're going to have a hydrogen, then we're going to have a hydrogen. So between these two, the highest priority is going to be on top. So what we're going to do is compare nitrogen to oxygen. And between these two, oxygen has the highest atomic number, so hence it's going to have the higher priority. So that means that this guy on the far right, this is going to be number 3, and then this one right here is going to be number 4. Okay, so highest, next, third, fourth highest priority. Okay, all right. So let's do the sub-question C. Okay, so these are our choices for sub-question C. Just going to move this guy up a little bit. So here we go. Okay, so the first thing we need to look at is the immediate atom adjacent to the attachment point. So again, the attachment points to our atom of choice are going to be here, 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 and here. So that means that we need to go 1 atom over. Okay. So for this case, we have to compare a chlorine to a carbon, to a carbon, to a carbon. So right here, it looks like we have 3 immediate ties right off the bat, which they're all carbon. So the only easy call to make here is with the chlorine. Chlorine is going to have a higher atomic number than the carbon. So overall, this is going to have the highest priority, this chlorine right here. So now what we have to do is we have to start breaking the tie for each of these other carbons. So let's call this guy carbon A. We'll call this guy carbon B. And we'll call this guy carbon C. Okay, and we're talking about this carbon right here. And again, it's not drawn out explicitly, but it's definitely there. Okay, so let's go ahead and do a branching tree for this guy. So this is carbon, it's carbon A, and so we're going to have to go ahead and put 3 groups. So remember, whenever we have a double bond, the way that we treat double bonds or triple bonds is that we actually treat it as if attached to this carbon there's not a single oxygen. We treat it as if there are 2 oxygens attached. So that's the way we would subdivide this guy. So we put 1 oxygen here, 1 oxygen here, and then the third is going to be this carbon right here, which would come from that carbon right there. Okay, so that's how we do the branching tree for this carbon A. For carbon B, we're going to have carbon B, and attached to carbon B, we're going to have a couple of different groups. So I'm just going to put this B down here. So first off, we obviously have an implicit hydrogen here, and then we also have a CH2 right here. Okay, so those are implied and understood. So attached to carbon B, we're going to have not 1 carbon, but the way we're going to treat it is because it's a double bond, we're going to have 2 carbons attached to carbon B. So here's a carbon, carbon, hydrogen. And so then going over to carbon C, we're going to have carbon C. And then now the way we treat carbon C is that we're going to have 3 groups attached, and they're all going to be this nitrogen. So we have a triple bond, so it's not just 1 bond to nitrogen for the comparison. Even though rigorously, in reality, there is only 1 nitrogen attached, the way that we break this priority rule is that we treat it as if there are 3 nitrogens attached. So nitrogen, nitrogen, and nitrogen. Okay, so right here we're going to start at the very top of the priority tree for each one, and we have an oxygen compared to a carbon compared to a nitrogen. So this is actually a really easy call to make. The carbon right here is going to be the lowest atomic number, so this guy is going to yield an assignment of 4 for this guy right here as the lowest priority. And then next up in terms of priority and in terms of atomic number is oxygen versus nitrogen. So oxygen is going to have the next, it's going to have the highest atomic number. So this particular carbon is going to be number 2, okay, because we've already assigned the highest priority going to this group right here. So that leaves the third priority to go to this nitrile group right here. Okay, so that's it. 1, 2, 3, 4. Overall, a really simple process. The big mistake that most people make is just assigning priority based on the size of the substituent overall, which again is completely incorrect. You have to take this atom by atom and compare by atomic number. Okay, and unfortunately, this is just a complete convention. It's completely artificial. And so it's just one of those rules that you have to learn to be able to communicate with other chemists.